Let's have a quick review on periodic table and see what are the properties and what does periodic table have. So the modern periodic table of the elements based on Mendeleev's earlier version. What is the organization of periodic table? Each element has a box that contains its atomic number, atomic symbol, and atomic mass. And the boxes lie in order of increasing atomic number as you move from left to right. The boxes are arranged into a grid of periods, horizontal rows, and groups, vertical columns. Each period has a number from 1 to 7. Each group has a number from 1 to 8 and either the letter A or B. A new system with group numbers from 1 to 18, but there is no letter for them. So when we have 1 to 8, we have letter A or B, or when we don't use the letter, we have 1 to 18. So here you can see this example. So these are all groups, as you see here, group number 1 or 1A, group number 2 or 2A, group number 3 or 3A, all the way to group 18 or 8A. So basically these transition metals are B's, and the rest on the left hand side and right hand side are A's. For example, group 1 is alkali metals, group 2 is alkaline earth metals, group 7A or 17 are halogens, and 18 or 8A are noble gases. So basically, in this side we have metals, and in this side we have non-metals. This side and this one are non-metals. The rest, most of the elements in the periodic table are metals. There's another one. As you see here, we have, for any box here, we have the symbol, atomic symbol, we have atomic number and atomic mass underneath of it. And here we have the name of the group, 1 or 1A, 2 or 2A, 3B, 4B, 5B, 6B, 7B. These three groups are 8Bs, 1B and 2B, and here we have 3A, 4A, 5A, 6A, 7A, and 8A. And here is the periodic table, and it is classified based on their time of discovery. So as you see this color, they are discovered before 1800. This one is 1800 to 1849, 1850 to 1899, 1900 to 1949, and 1950 to 1999. So basically all these elements are newer comparing to all other elements. So let's see what are the difference between metals and non-metals. So most of the elements are metals. Metals have characteristics such as physical properties such as efficient conduction of heat and electricity, malleability, and ductility property. Chemically, metals tend to lose electrons to form positive ions. So metals lose electrons to form positive ions. That's why they are called cations, after they lose the electrons. For example, copper is a typical metal. It is lustrous. It is an excellent conductor of electricity. On the other hand, we have nonmetals. The relatively few nonmetals appear in the upper right corner of the table, as we saw, except hydrogen, a nonmetal that resides in the upper left corner. We saw that one before too. So if I go back here, we have hydrogen. This is the nonmetal, but it's here. The rest of them are here. So nonmetals, chemically, they tend to gain electrons in reactions with metals to form negative ions, which are called anions. Nonmetals often bond to each other by forming covalent bonds. We will see what does that mean, covalent bond. What are groups or families? The periodic table is arranged so that elements in the same vertical column called groups or families, and they have similar chemical properties. So elements belong to the same group or same family. They show similar chemical properties. For example, the first group is called alkali metals. All the alkali metals members of group 1A, lithium, sodium, potassium, rubidium, cesium, and francium, are very active elements that form ions very fast. So they lose one electron and becomes 1 plus charge when they react with nonmetals. Alkaline earth metals, group number 2A. So these are all belong to group 2. Beryllium, magnesium, calcium, strontium, barium, and radium. They all form ions with a 2 plus charge when react with nonmetals. On the other hand, we have halogens. They are nonmetals. They're members of group 7A, and they are fluorine, chlorine, bromine, iodine, and astatine. All form diatomic molecules like Cl2, F2, I2. So they form ions with a 1 minus charge. Noble gases, the members of group 8A, helium, He, neon, argon, krypton, xenon, and radon are all known as noble gases. They all exist under normal condition as monatomic gases and have little chemical reactivity.